Alright, say 5b. We're going to do another partial fraction expansion to find this telescoping series, the sum of this series. To do so, again, we need to factor the denominator. So factoring the denominator, we can get 4 over, if you factor that denominator, we can pull out an n times n plus 2. And so we're going to write this as two fractions, a over n plus b over n plus 2. One fraction for each of those denominators. And what are we then going to do here? Well, we're going to find a common denominator. We're going to smush it back together so that we can figure out what a and b have to be. And so to do so, we're going to multiply by n plus 2 over n plus 2 on the first fraction. So n times n plus 2 right there. And then in the second fraction, we're going to multiply by n, because doing so gets us that easiest common denominator. So now we can smush it all together, a times n plus 2 plus b n over n times n plus 2. And so now we need to focus on this guy and this guy, the thing we started with. 4 over n times n plus 2 will equal what we have over here, a times n plus 2 plus b n over n times n plus 2. And the denominators are equal, which means the numerators have to be equal as well. So 4 equals a times n plus 2 plus b times n. And we want to know what a and b are, and this needs to be true for all values of n. And so we can choose a couple special values of n to simplify this. So if we choose n equals 0, our b term will cancel out, and I'll get 4 equals a times 0 plus 2 plus b times 0. So b is gone. 0 doesn't do anything, so I just have 4 equals 2a, which means that a equals 2. And I can choose a similarly useful n value to cancel out my a piece, and I will choose negative 2, because then I'll get the equation 4 equals a times negative 2 plus 2, which is 0, so that cancels, plus b times negative 2, which means that I have 4 equals negative 2b. And so divide by negative 2 on both sides to get b equals negative 2. 4 divided by negative 2 is negative 2. So I found a, I found b, which means I can write my fraction now. This original piece up there, a was 2, so 2 over n, plus b is a negative number, so I'm going to say minus 2 over n plus 2. And again, we're saying that this is equivalent to 4 over n times n plus 2. And like I did in the last video, you could find a common denominator, smush it back together, and show that, yes, those two things are indeed the same. But the point is, I can now use this up top in this original summation. I can rewrite this summation as the sum from n equals 1 up to infinity of, instead of 4 over n squared plus 2n, I can write it as 2 over n minus 2 over n plus 2. And again, you don't see the benefit of this until you start listing out terms. So let's list out our first term. When n equals 1, I get 2 over 1 minus 2 over 3. And that is when n equals 1. And then let's do the same thing for n equals 2. I'll get 2 over 2, plus 2 over 2 minus 2 over 4. And that was my second n term. And I'll do it for n equals 3. I'll get 2 over 3 minus 2 over 5. And that was n equals 5. And let's do one more. Notice at this point, though, that I already have a pair that will cancel out. So let's do one more just for good measure. When n equals 6, I'll get 2 over 6 minus 2 over... Well, I just went crazy. I goofed that up. That was not n equals 5. That was n equals 3. So my next one should be n equals 4. So I get 2 over 4 minus 2 over 4 plus 2 is 2 over 6. So that was my n equals 4 right there. And now I can see that I have pairs that are canceling. I have a minus 2/3 and a positive 2/3, so those cancel. I have a positive 2/4 and a negative 2/4, so those cancel. Maybe you want to do one more just to be totally convinced that we have all the pieces that are going to cancel. If we did n equals 5, we'd get plus 2 over 5 minus 2 over 7, and then that would cancel with that right there. So we have our canceling bits, and what's going to remain? Well, the only things that will remain are going to be this original 2 over 1 right there, and that 2 over 2 right there. Everything else is canceling. That will cancel with the next one. That will cancel 2 down the line. They're always canceling, so we're just left with 2 over 1, which is 2, plus 2 over 2, which is 1, and so this sum is 3.